Hi, welcome to week 2 of the online advanced Python class. Today I will be teaching you about object-oriented programming. What is object-oriented programming? It's a way of organizing your program in terms of objects. An object has variables that are used to describe an attribute of an object and functions to describe what an object can do. So it is a way of combining data and functions together into what is called objects. What kind of objects can be described? About anything. In order to give you an idea, we will look at an example where we will use objects to describe different types of animals. Along the way, we will learn about object-oriented concepts like class hierarchies, inheritance, class variables, overriding methods, just to name a few. So the transcript of this video should also be made available to you, so you don't need to take as many notes. The transcript will include screenshots of the code that we will be developing here. Also, this is being taught as an example. In class, you will be applying the concepts to a completely new project, a banking project. So you really don't need this code for class. So with that, let's get started. Here we have a class definition in Python. The class definition starts with the keyword class, followed by the name of the class name, in this case dog. So this class is a kind of a blueprint describing the type of object, in this case a dog. This class will describe the functions associated with this type of object, basically what the object can do. In this case, we're describing a dog. What do we want this dog to do within our program? Well, this is just an example, but we're going to create functions for it to eat, sleep, walk, and run. And these functions, when they're inside a class, are also sometimes called methods. And what these functions will actually do is just print out a message that says something like the big brown dog named Ralph ate a bone, for example. And similarly for sleep, walk, and run. You'll notice that I'm using string substitution a lot here. And hopefully this is a concept that you're already familiar with, using the @ sign to take values and substituting them into the string. This is a concept that was taught in beginning Python, but I'll be using that a lot here. You'll also notice that we also have a function called __init__. This is a special function called a constructor that automatically gets called when we create an object of a class. The first parameter of any function within a class is always self. This is a variable that refers to the object being created in the case of the constructor, or being operated on in the case of the other functions. Variables can be assigned to an object, which describe the object, which are also called attributes. What attributes does a dog have? Well, in this case, we're going to limit it to a number of attributes: name, size, and color. And these attributes are going to be specified when we create the object, so they're going to end up being parameters that follow self. So self is always the first parameter, but then the other parameters of the constructor can be whatever we want them to be. But in this case, typically it's the attributes that we want to assign when the object is created. We can assign an attribute by simply referring to the object, again self refers to the object followed by a dot, and then the name of the attribute that we want to set, and then we set it to the parameter name that we pass in. And that way, this dog gets whatever name we specify. And then same thing, size and color. So now let's look at our main program here. This is where we actually create our first dog object. Create the object by referring to the class name, and within parentheses specifying whatever parameters are indicated in the constructor. So in this case, they are name, size, and color. We don't have to specify self because, again, self is referring to the object itself that's being created. So in this case, we create a dog named Ralph, and his size is big and his color is brown. And so now that I have created the dog, I assign it to this variable. And once I've got it assigned to this variable refers to this dog object. I can refer to the object using the variable, and if I want to refer to an attribute of the object, I can do that by simply following the variable name by dot, and then whatever attribute of the object I want to refer to, like name. So I can say print the name of my dog is, and then this should be Ralph, because that's what we assigned the name attribute was assigned to Ralph. And similarly, the color of my dog is brown. I can also call these the functions within the class, which are also again called methods. And I call them by again referring to the object through the variable followed by a dot and then the method name. Now in the case of methods, basically a function, so like you call functions in Python, you have to follow it with the function name with a left paren or right paren and specify any parameters that the function requires. Now in this case, eat requires a parameter specifying the food that the dog is eating, in this case a bone. In the other cases, there are no other parameters. So for sleep, walk, and run, it's just an empty, there are no parameters. So let's run this and see what happens. So I run this, and you see here it says the name of my dog is Ralph, the color of my dog is brown, the big brown dog named Ralph ate a bone. That came from this line here. The big brown dog named Ralph fell asleep. The big brown dog named Ralph walks. The big brown dog named Ralph runs. And that's basically the execution of these four methods. Now I'm going to show you a special trick that's really useful in looking at objects in Python. Every object has an internal dictionary attribute called underscore underscore dict, dict underscore underscore. And what this attribute is actually it's an internal attribute associated with the object that actually is a complete dictionary of all of its attributes that you assign this dog. So when you print out the dictionary of the object, you're going to see all of the attributes. So let's run it again. And you'll see at the top here, you see the name of the, you see a name attribute assigned Ralph, a size attribute assigned big, and a color attribute that is assigned brown. So all of the attributes of the object. We assigned these attributes within the constructor. You can also assign that or modify attributes within the constructor, within functions. You can also do it outside the class as well by just simply referring to the object. Like for instance, I can say, if I want to change the name of my dog, I can say my dog dot name equals Snoopy. And now when I run the program, you'll see that it's still named Ralph at the beginning of the program, but then I changed the name to Snoopy, and then the next line it says the name of my dog is now Snoopy, and the rest of the program is the same. I can also add new attributes that were not assigned previously. Like for instance, I can create an attribute called breed and assign it a string called beagle. And then I can refer to that later and say, for instance, the breed of my dog is dot breed. And now if I run that, you'll notice that it says the breed of my dog is beagle. So you can assign attributes, new attributes to an object if you wish. Okay, so let's again print out the dictionary just to show that new attribute was indeed assigned. So now I will run it again, and you'll see that on the second line it says name is Snoopy, size big, color brown, and breed. Breed was added to the dictionary. So again, the printing out dict is the dictionary of an object is pretty useful, and particularly in debugging and being able to see what the object actually has in it. So let's see what happens if I simply try to print the object using the variable. So I run it, and what I end up getting is, in Python, it's always going to try to convert whatever you print into a string, whether it be a variable, a list, a dictionary, or even an object. It's going to try to convert it into a string and then print it out. In this case, it prints the object by default gets a string representation that looks like this. Basically, we can tell that it's a dog and it's at some memory location. But that's not really what we want. Looks kind of strange. We'd rather have a description of a dog like this. So let's do that. We can do that because there's a function called underscore underscore str underscore underscore, which is by default generates this kind of representation that we saw here, but we can change it to whatever we want. And again, the first parameter needs to be self. And what we want is for it to, what this function does is it returns a string representation of the object. So we need it to return something like that. And so let's again run it. And so now I see instead big brown dog named Ralph. That's better. And we can also do something like, let's put it after this one. We can do string substitution. Like for instance, I can say my dog is a, and then use a percent %s, and another % here for the string substitution, and then specify my dog, which is again the object. It's going to convert the object into a string and then replace it into this string. So let's try that out and see what happens. So I see my dog is a big brown dog named Ralph. Perfect. So now that I have this string function here, I can actually use it in these other methods as well. Instead of having to pass in all of these, use all of these attributes and putting the string together each time, I can just use the string function. So let me show you another version of this project where I've already done that, kind of simplifying things in here. So here, now I have my string function as I did before, and in the other methods, I'm simply now, instead of specifying all the attributes, I just specify the object and let the object be converted to the string format and substituted into this line. And I do that for each of the eat, sleep, walk, and run. So let's run that and see. You'll see that I still get the same thing as before. The big brown dog named Ralph ate a bone. Because self is referring to the object, it's now being converted to a string using the string function, substituted into this string here, and then we end up with this. Now let's say we want to add some other type of animals as well. We will add a pig, a bird, and a fish. We will add a new class for each type of animal. All of these animals eat and sleep, and so the methods for these actions may be exactly the same. In this case, we don't want to duplicate these methods for each class. Instead, we will first create a class called animal, which will hold the common attributes and methods of all animals. And we will then make the classes for the different type of animals subclasses of animals. So what I'm going to do here is I'm going to change our dog class into animal class. And it's going to have the same constructor as dog did. Also, all animals can eat, all animals can sleep. Not all animals can walk and run. So this is where I'm going to, again, define my dog class. But this time, I'm going to make dog a subclass of animal. And the way I do that is I put the parent class in parentheses behind the class name, like that. That makes dog a subclass of animal. What that means is that a dog has its own methods like walk and run, but it is also an animal, so it can also sleep and eat. And also the string function is referring to animal, which is what I want, but I don't want it to specifically say dog because it could be another type of animal. Ideally, what I want is for it to, if it's a bird class, I want it to say bird. If it's a fish class, I want it to say fish. So I basically wanted to say the class name. And so let's generalize this function to do that. If I make a variable called animal type, which is going to be a string, and I set it equal to the class name of the object. And the way I do that is I refer to, there's an attribute, an automatic attribute called class, which is actually a reference to a class object And then in that class object has an attribute called name, which is the name of the class. That should return the name of this object, and the name of the class of this object. And the Python convention is to always use capitals when creating a class name. And you'll notice I've done that to follow the convention. But here I don't want the capitalization. So what I'm going to do is, since name is a string, I can use a string a string function called lower to convert it to lowercase. And then instead of dog here, I'm going to have another string substitution. And that string substitution is going to be this animal type variable. And that should do it. So if I run this, it should in fact run exactly as it did before. The sleep and the eat methods are now part of animal, but since dog is an animal, I can still run them. You'll notice that I still get the string, the description here that says dog because it is a dog, and that's now coming from the class name being converted to lowercase. Now let's consider these methods under the dog class, walk and run. Other animals actually walk and run. Lots of animals walk and run, not just dogs. If we're going to create a pig or a bird, they both walk and run. However, a fish does not. And we don't want to duplicate these methods underneath each class again. We want to have a common class for all animals that walk. So if we create a class called walking animals, which would include dogs and pigs and birds, but not fish, then we can include these methods under that. So let me show you a slightly different project. Okay, here we have our animal class as we did before. However, we've added a walking animal class. This is for all animals that can walk. And we have underneath that, we have our dog class. So let's look at this walking animal class. So first of all, we've decided to add another attribute, an attribute that all walking animals have. It's all walking animals have legs. So we decided to add this attribute. And because of that, we need to have a slightly different constructor because we want to pass this legs attribute in the constructor. But we want to take advantage of the animal constructor. So what we do here is within the walking animal constructor, we actually can call the animal constructor. And that's going to go ahead and assign the name, the size, and the color. And then the only other thing we need to do in the walking animal constructor is assign the legs attribute. And that's going to be the number of legs that this walking animal has. And then you'll notice that I have changed the walk and run slightly so that it actually takes advantage of that attribute. And you'll notice that this attribute happens to be an integer number instead of a string. So I'm using, in string substitution, I'm using a %d instead of a %s. Now that I've moved the walking and running to walking animals, there are no methods left in dog at all, except now I need to have a constructor. By default, it would inherit the walking animal constructor, which includes the number of legs. Well, we know how many legs a dog has, and we don't want to have to specify that in the constructor. So we create its own constructor, which again only specifies name, size, color, those things that we don't know. And then we again call the constructor of the superclass. Now, whenever you want to do that, this is how you do it. You say super and then dot underscore underscore init underscore underscore, and that's going to call the constructor of its parent class or superclass. And in that case, we need to pass all of the parameters that the superclass requires, including the number of legs. But we know the number of legs of a dog is 4, so we're just going to pass in 4 there. All right, so that's pretty much it for dog and walking animal and animal. You'll notice that I also added a bunch of other animals. I added a fish, I've added pig and a bird, eagle, and an ostrich. Okay, so now that we have a good number of classes defined here, it's sometimes useful to actually have a diagram that shows the relationship between the classes. And so I wanted to show you this diagram. This is called a UML class diagram. And it's basically just to show the relationships between classes. And this is one specifically for the class hierarchy that we're developing here for the animals. And each box represents a class. And within the box, it might be divided into segments. If it is, then the top segment is the name of the class. The middle segment are the attributes of the class, and the bottom segment is the methods of the class. If they're not shown, it's either because they don't have attributes or methods in themselves, or you chose not to use them or show them. This is really for your benefit. This is not required. It's just useful to kind of get a big picture of what all your classes look like and their relationship. So underneath the top level class, which is animal, you see walking animal and fish. Both of these point using arrows to their parent class. So we know that walking animal is a subclass of walking animal is a subclass of animal as well as fish. And dog and pig and bird are subclasses of walking animal. And we even defined ostrich and eagle, which are subclasses of birds. And you'll notice that the fish has its own method. Fish can swim. Birds can fly. A bird is a walking animal, so it can also run and walk. And all of these animals can eat and sleep as well. So let's look and see what this looks like in Python. So we already looked at walking animal and dog. Fish is an animal. So it's a subclass of animal and it has a swim method. Pig is a walking animal and it, like the dog, doesn't have any methods other than it does have a constructor because it's slightly different than its parent. The fish did not have a different constructor, a special constructor, because it just inherits the one from animal, and that was fine in that case. Bird also is a walking animal. It has a constructor. You'll notice that in its constructor, the number of legs is 2 instead of 4, because birds have 2 legs. And it also has a fly method. And then eagle and ostrich are subclasses of birds. And the eagle and the ostrich, really there's nothing to specify here because we don't have to specify a constructor. The bird constructor is fine, and it has a method fly. And so there really is nothing that needs to be defined here, but you have to put something down here. The Python compiler requires it. So we put pass, which just basically is a placeholder indicating that it does nothing, or it's an empty class except for what it inherits. And then we have we've added a bunch of statements for creating a pig, creating an eagle, an ostrich, and a fish, and running their various methods. So let's run that and see what happens. So we see that the small pink pig named Stanley ate an apple. We see that pig is being shown here. This is being taken from the class name. Remember, we generalized this description to use the class name as the animal type. And then we also have the eagle, the ostrich, and the fish. Now let's talk about the ostrich. The ostrich is actually a flightless bird. It cannot fly, but this statement says that it flew away. So, well, that's because it is a bird. An ostrich is a bird and therefore has to have a fly method. And by default, it inherits the fly method from the bird class. Well, ostriches, as we know, are a flightless bird. So we're going to fix that by, it has to have a fly method because it is a bird, but we can give it a special fly method, its own fly method. And so what I'm going to do is I'm going to paste in a new fly method for the ostrich. And this one basically says the ostrich flaps its wings but cannot fly. And this is going to override the fly method from the bird class. So this is what's called method overriding. When you define a method, the same method that's defined in a superclass, but redefining it to do something special. So let's run this. And now you see that the ostrich named Olivia flaps his wings but cannot fly. However, the eagle, who is also a bird, still can fly away because the eagle is inheriting its fly method from the bird class. Okay, the last thing we're going to talk about in this video is class variables, sometimes also called static variables, but I prefer class variables because these are variables that are associated with the class directly and not associated with any particular object. Let's say that we wanted to keep track of the number of animals that we create. Well, what we could do here is that we could create a variable called count. And this is a class variable, and we're going to initialize it to 0. And it's a class variable because it's associated directly with the animal class. It's not associated with any particular object, because if it were, I would have to put self in front of count. But since I'm defining it here directly under animal, it's a class variable. Every time I create an animal, I want to increment this count variable to keep track of the number of animals. Now, the way we coded this, all the constructors, no matter what kind of animal, is eventually going to call the animal constructor. So every time the animal constructor is called, I can increment this variable. Now, here I need to refer to it, I have to put animal dot in front of it. That's the class name because it's a class variable. And I want to increment it by 1 every time an animal is created. Now, what I can do is in the main program, I'm going to cut and paste this print line, print number of animals is equal to, and again, I refer to it as it's a class variable, so I have to put animal in front of it instead of an object variable. And I want to put that at the end as well. So let me copy that again and paste it at the end. And now let's run it. And what we see is at the beginning, even before we create any objects, so no objects created, we can still refer to this animal.count variable. And at initially 0, which is what we expect. And then after creating a dog, a pig, 2 birds, and a fish, the final number of animals is now 5. So that demonstrates the use of a class variable. So that's it for this video. I hope you found it educational and useful. And we will talk to you later.